Right, so
So what was V? V was one
square
half.
root K square root M of R. That's your first box there.
Okay.
There it is. Next one, choice. We like those. This is the ASTC problem, it looks
Mhm.
like. Uploading now. There it is. Yeah, so we kind of talked about how it's like a light switch or a binary thing here.
Mhm.
You have A, S, T, C, A meaning all positive, S means sine positive, T means tangents positive, C means cosine positive. So sine is greater than 0 in two quadrants, first and the second, because they're all positive in the first, and then sine is positive in the second. Tangent is negative. Well, where is it negative? Well, it can't be where they're all positive, and it can't be where tangent's positive, so it's in the second and the fourth, and you're looking for the overlap, which is in the second quadrant. Is that okay? Clear?
Yeah, that one's clear.
I mean, I don't know how you show work other than what I've
Yeah.
got here,
Yeah.
but
Yeah.
not a ton. Um, okay, so yeah, this one looks like it's a little bit more involved. Um, it's uploading now. So let me snip this in. All right, so it says a rectangular piece of plywood 8 by 12, 8 by 12 has corners cut from it as shown in the figures on the right. Just the two corners. Find the perimeter of the remaining piece. Okay, so they're basically you've got to find the hypotenuse of each of these triangles here.
Okay.
One of the important things here is for you to recognize that it's a 45, 45, 90. Did you guys talk about that in class or in your lectures?
Yeah.
Okay, so the reason that's important is that the hypotenuse is always the leg times the square root of 2. So this up here is 2 square root 2. And then same thing over here on the top right, because both the legs are 1, this is 1 square root 2. So your perimeter is the way you calculate perimeter, you have to also deduct out like what's going on here. So you might actually want to redraw it here just to have it where it's a weird piece anyway. This is 11. This is 11. This is 7. This is 7. And then you got 2 root 2 and then root 2. So now you're just adding all those up. Like that. And this is probably reasonable for showing your work. So it looks like it's 36 plus 3 root 2, which is weird because they don't have that as one of the answers. They have 40 minus 6 plus 3 squared. Sorry, 40 minus, wait, 18, 36. Oh, 7. Sorry, I'm just looking at, like, I guess none of these answers are matching up because they're adding and subtracting. So they're doing it differently. All right. They're doing it differently, so let's do it their way. They're doing 12 plus 12 plus 8 plus 8. And then they're subtracting out the 1 and the 1, subtracting out the 2 and the 2. So they're subtracting out these two sides, and then
Mm-hmm.
they're adding the 2 root 2 plus the root 2 to get there. So they're doing it this way where they're saying, okay, that's minus 6, and then this is the 40 minus. So my mistake is over here. This is actually 6 and 10. That's why it wasn't working out. Okay, so it's 40 minus 6 plus 3 square root of 2, which is option C. There. Sorry for the scrolling. Now let's
You're
get to
fine.
some of the other answers. All right, so for the next one here, it says the exact perimeter is, and that's all you're doing is just subtracting this. I mean, that's what we had before. It's 34 plus 3 square root of 2. That's going in the first box. And then the units are in feet. And then the decimal form, you're just putting this into the calculator, rounding to 1 decimal place. It's still in feet for sure. And I get 38.2. Please double check me, especially since
Okay.
this is for a score that counts.
Eight point.
It's the next one. There it is. Uploading. All right, I'm gonna get it snipped in here. Take a look at it. All right, suppose that 60% of a particular group of people have a systolic blood pressure reading of 140 plus or minus 6.25. Let x equals a. Let x equal a blood pressure reading among the 60% just described. Write an absolute value inequality whose solution set is the range of possible blood pressure readings within plus or minus 6.25 of 140. Okay, so the formula here is that you take your variable, you subtract the center, and it's less than or equal to the width. So in your problem, 6.25 is the width, and your center is 140. This gives a solution of 146.25 to 133.75. So this is what they're looking for. And the formula there above is probably one they would have given you in class at some point to model the situation.
Was that 33.75?
Yeah,
Okay.
133. But
Okay.
you don't need that. That's just
Okay.
extra information. I mean, it's the there's not really much to do in terms of work,
Okay.
showing work here, because it's a known thing.
Okay.
Next one here looks like it could be a little different than what we've been
Yeah, I don't remember seeing this one.
doing. Yeah. All right, photos. All right, did upload. All right, so now, um, where is that? The Google Photos doesn't auto refresh, so it's like waiting on that
Okay.
each time. But here we go. Um, Magnitude, standard position, angle. Uh, oh, and the horizontal. Okay. I'm gonna snip in the question and then the picture, and then okay, so the question here is asking you to resolve vectors A and B into the magnitude, which is like this number here,
Hmm.
and its standard position angle. So like the 98 is completely horizontal.
Okay.
So its standard position angle is 0. The 80, but the problem is standard position is like that. So I think we're gonna having make this 180, which is what I want to check, which is weird because you don't actually do this in physics. You would just assign it negative. The other one is 83 pounds normally it would be 17, but I think because it wants standard position from the horizontal here, it's going to be 197. So I just want to check, the wonderful internet here and see if I can find a problem like this. Otherwise, I'm just guessing about what it
No, that's
wants.
fine.
So give me just a moment here to do that, and we'll see if I can't make some sense of this. If you ever go out to the internet, just make sure what you've seen has like upvotes or positive feedback because it's really
Yeah,
easy to,
there's a lot of them. I noticed that.
yeah,
'Cause
you just want to be careful. Yeah.
yeah, because I use that Chegg program, and I noticed there's a lot of wrong answers in there. So
Yeah, that's the concern. Um, Outvoted. What's in the first drop? What's in this drop down here?
sure,
Uh, Hopefully,
below
maybe
or
it's,
above.
yeah, that's interesting. So standard position. Yeah, again, like it's like, well, what is the standard position? It is from there. Yeah, okay. I think this is okay. I guess I would recommend going with this. So the next part is like we're trying to figure out what the net angle is.
Hmm.
So to do this, you're supposed to resolve both vectors into their horizontal and vertical components. So how to do that? In the x direction, it's 98 cosine 180. And then the other one is plus 83 cosine 197. And then the y direction, there's nothing from the first one, although it would be written this way, 98 sine 180, which is 0, plus 83 sine 197, um, like that. And so we want these two values, and then to find I'm gonna call this R for the moment, and this theta. R is the square root of x squared plus y squared. So what I would do is I would go to Desmos and I would like call this X, call this Y and do this. And then the angle is the tan inverse of Y over X, like that. So I'll do some of these calculations here so you can have them in case you want to look at it later.
Okay.
You'll do this all the time in physics if you end up taking a physics class. Make sure your mode is in degrees. So got it here for you.
Now, when it says to round to the decimal, do you put 0.0 for that um second one or the 179?
Yes, the answer is yes, and then the angle is
7.8.
7.8, yeah.
Okay.
So the last drop down is below. And the reason it's below is because of the fact that tangent of the angle is positive. So it means it's either here or here. But we kind of know graphically that it's going to become like you can imagine these two kind of pulling together. It's going to be somewhere kind of in the middle, which
Mhm.
is below. Um, this will be below.
All right.
Those like one we might have done previously, so that's good news. I take that back. This is just some sort of that's what's called a literal equation, no numbers, and you're just solving for something inside the equation there. In this case, looks like it's B2. All right, so let me just grab the equation only. Doesn't really matter what the physical situation is. They're just telling you, hey, you got to solve this for B2. So to do that, we a couple of things we could do here. We first need to get rid of this 2. So we're going to divide both sides by 2 like that. Gonna be a lot of rewriting. I guess you do have to show your work here, so that's maybe a good thing. Divided by 2 equals log base 10, B2 over B1, like that. Next thing is to undo log base 10. So you do that by using a base, and you can actually just show it like here, like 10 to the power of this. So this is an exponent, this is an exponent, and it undoes the log. On the left, it doesn't undo anything. It just is the exponent m1 minus m2 over 2. That's the exponent equals b2 divided by b1. And then you clear out the b1 by dividing both sides or multiplying both sides by b1. And you can see those cancel. And that's your final answer here for B2. B2 is equal to B1 times 10 M1 minus M2 over 2. So main thing, just make sure your formatting is good. You know, this is in the same line, this is in the exponent. That should be sufficient for that. All right, there's the next one. Looks like maybe one we've done previous lesson here, some sort of triangle that we're solving. I think we'd used law of sines last time. All right, there it is. All right, find the total length of the laser beams shown. Okay. I guess we can do this first question. Multiple choice here. Okay, it says find the total length of the path of the laser beam that is shown to the right. So we assume it starts here, boom, goes up, comes down. We did an airplane problem like this. It's really just a triangle with some angles and sides. We need to know the total length of the path of the laser beam is the sum, add them up, the lengths of the line segments. And we don't have a ton to go off of right now, but I'm going to redraw this without all the words. This is 33.5. This is 102.7, and this is 6.51. So we're going to use law of sines to solve this thing. What we need are the other two sides. So we're going to first find, I'm just going to call this B up here. To find B, B over sine big B equals 6.51. Sorry, let me not do it that way. A over sine A, because you got to show your work. We'll call this A. We'll call this A, this big B, this C, and then this little c there. Okay. So the reason I'm choosing these is we want to find B, and we have the angle across from it.
Okay.
We need a known side angle pair, and we have that here with A. And I'm just arbitrarily choosing A. You could use a different letter if you want.
Okay.
So it's B over sine 33.5 equals 6.51 over sine 102.7. And then you solve for B. Sine 33.5, sine 33.5. And so that is the answer for B. What we're going to do is we're going to calculate this to, it says to round your answer to 2 decimal places for the total. Let's round this to at least 3 decimal places when we go to the calculator there. And then we have to do the same thing to find side C, and then we have to add them all up. So I'm going to go back to calculator here. Let's see here, A, B, and that. So it ends up being 3.683, which is reasonable. It's like the same order of magnitude as 6.51. It's not like a ton bigger, a ton
Weird.
smaller.
Right.
Okay. And then we're gonna do the same thing to find C, except this time we don't have the angle up here. So to find the big angle C, you have to subtract the other angles from 180. That ends up being 43.8 degrees. So now we've got basically the same setup. C over sine big C equals A over sine big A. You generally want to reuse the known information here. So it's C over sine 43.8 equals 6.51 over sine 102.7. And then you solve for C just the same way here. Clear out that and you end up getting C equals 6.51 sine 43.8 over sine 102.7, like that. And then that ends up being 4.619. And then your total length here, not all questions are created equal. I don't have it in, I'm snipping the rest of it. Yes, I'm still here. Hate how things time out on. Where do they think I went?
Yeah.
Yeah. So you have to add up A plus B plus C. A is the 6.51. And so you've got all the other values there to add up. So A plus B plus C. I guess I don't have A, 6.51. All right, so I get 14.81, and then units. I don't know, what are the units here? Centimeters. Like that. And then I'll snip in all these calculations in case you want to look at them later. This is more of a programmatic way to do it, but it works really well. There it is. That's uploading. This also looks like something we have not done. But let's take a look here. It says disk spins at 1500 uh, R per minute.
Revolutions.
Well, yeah, it could be revolutions, could be radians. I don't know why they would just use the letter R, but yeah,
Right.
something like that. Revolutions per minute sounds good. When the innermost edge is being read by the laser and gradually slows to a rate of 680 revolutions per minute at the outer edge. The idea is that, and I think the best example is, let's say you're here and you have a friend here, and you guys want to run around this circle. Person running on the outside has to run a lot faster than the person running on the inside to maintain this sort of always where you're always at the same place.
Right.
Okay, so that's why there's so much different here. So it's using inequality to express the angular velocity W of the disk. I mean, I think really all this is asking for is 650 less than or equal to, and make sure you use, it's really omega. It's a Greek letter. Make sure you use the Greek letter, not W, is 1520. I think this is all it wants. It's just saying like it's going to be anywhere between those two values. Question 9, loading. What do we do? Okay, this one is a solving problem, I think, for a variable. It's kind of like that other literal equation we did. Oh, this one's actually got, that's an x-intercept. Okay. And you have to do this by hand. Unfortunately, if you didn't have to show work, you would just graph this. So the x-intercept of this is where it crosses the x-axis. So this one, I'm finding it's wrong, but it probably looks something like that. It crosses the x-axis somewhere. So it crossed the x-axis when y equals 0. 0 equals 14 minus 9 to the x minus 1 power, like that. So we're basically solving for x. We're going to solve for x and then put that into the calculator. Now, most of the time you would subtract the 14 from both sides, but I'm
Mhm.
gonna actually recommend moving this to the other side just to make it everything positive. The kind of the shortcut is to just put an equal sign in between the two because they're both positive. And then you undo the base to get to the exponent by using log, and then you can use a base, but the more common approach is to use ln. So you take ln of both sides, natural log of both sides, and then you bring the exponent out in front. So this becomes natural log 14 equals parentheses x minus 1 times the natural log of 9. The reason that x minus 1 is in parentheses is both of them are multiplying this. Really, it's implied up here that it's in parentheses.
Okay.
Then you divide both sides by the natural log of 9. And so that gives you x minus 1 equals natural log 14 over natural log of 9. You don't really need the parentheses anywhere. I just was using them for like visual separation.
Okay.
They're not really needed. And then you add 1 to both sides here to get that. So x equals natural log 14 over natural log 9 plus 1. And then this is where you go to your calculator. Some students like try to do it like they'll do in between steps in the calculator. Really want to wait until the end to do this. And it's at 2 decimal places, I think, in the question. Let's take a look here. Yeah, 2
Yeah, two.
decimal places. 2. So again, always good to double check me
Okay.
on this. So whenever you get this down, we're gonna go ahead and stop here for the hour,
Okay.
and then just reuse that other link for the next one. Leave
Sounds good.
plenty of time to get through everything, but
Yeah.
I need a short break. I'm sure you do
Sure.
too,
Yes, I do.
and I'll see you shortly.
All right. Thanks. Bye.
Thank you. Bye.